Йо, собаки, Наруто Узумаки. Так. Так. Мгм. А, все, можно не делать так. Мы с Пузанковым договорились, что типа теперь вы просто отмечаетесь у меня и все. Today we are studying together with Puzankov's class because you have online class so today and she cannot able to explain anything because he had caught a cold. So it's the reason why we have more than online or offline students today. Okay, so now today is midterm explanation. Actually, I think we'll start from the seventh task because it seems the most interesting one. Other one, I hope most of you solve it easily. Okay. Let's go to this one. I coded it, so I will present the code in MATLAB and in GeoGebra. Idea is following. So, first of all, if you know that regular quadrilateral pyramid should have not only edges but also lateral edges should be equal. In this case, how can you solve this task? Okay, so it means that AC and not AC, SA and SA should be equal. But we saw we're looking at 3 square plus 2 square plus 6 square, it's 36. And SA, oh, it doesn't matter, okay. 1 plus 16 plus what, 4, we can see that it's not equal. And we can say, okay, we can also solve this task by contradictory, 6 out of 6. Hooray, easy 6 score. But if you were me, who didn't know about this killer feature, you can solve this task in different manner. And I will present it precisely in this case. So in our case, let's assume that we know that it's quadrilateral. I mean, we know about this edges from the base. All base edges are equal. We know about this. But let's drop regular from this part. So we assuming that our lateral edges shouldn't be equal. And let's solve this task. Of course, in this case, it seems that we will omit these tasks because it's common task from this type of tasks. I mean, when we have some figure stereometry. I hope you know that this one equation from Google, this one, distance from vertex and plane. We have this equation also from slides. We had it, and you had also the task on midterm. And the distance between two lines, I hope it's not so difficult for you too. So we will stop on the A part because it's more complicated. Let's go to GeoGebra and watch our. So first of all, what we need to get that we have infinite number of solutions. Why? Because we cannot uniquely consider B and C points, so B and D points. So how should it look like? I make a variable there, angle 0, and you may see it's our solutions. Of course, in this case we have some singularity in somewhere else, somewhere there. I mean, because in this case it's reduced to the plane. But let's drop this part because you can easily find this, I mean, this angle and solve that it won't work because you will, how to say, you can check that it won't make, how to say, you will see the plane, not other points. Okay. How to solve this task? There are plenty of ways of this, of course, but one of possible ways, as for me, it's actually this task was made for checking your deep knowledge and changing the basis, because using this way you can solve this task. How I solve this? First of all, I decide, okay, I need to find some bases. This basis. So we have S, A, C, B, D. I decide that my basis will be X, Y, Z. It is my assumption. Not assumption, my destination point. Why like this? Because actually after this I can easily rotate this basis. Actually our global idea that we need to find this basis and after this rotate it on some particular angle, our variable. And we can find, how to say, this point each time. Actually we have circle. We can solve it differently. Why I didn't assume that we have point tag? Телефончики кыш. Okay, so like this. What's the problem? The problem is that, of course, we have equation of the circle. What we know about it? That's it in 2D. I hope you know this parametric form that x equal a cosine theta, y equal a sine theta, our circle. But it's in 2D. In our case, we need to rotate some particular points in 3D. In this case, how can we do it? Of course, if we make transformation matrix, because we need to transform our 2D in our particular place and work with it. It's the reason why I decided to not do like this, because actually in the end I did it, but using other ways. Now, so the first global task is, subtask, to find coordinates of this basis. Of these vectors. How? First, so actually I received this in the end, but originally I have a bit another story. So I made the code in MATLAB. First of all, I say, okay, we have a plane SAC. How can I find the equation of plane? We have 3 points, we find determinant of it. I wrote it there, determinant x, y, z, and blah, blah, blah. Because s equal to 0, I put it in the first point. Okay. So, у вас онлайн объединили. Она не отменила, вам сбросили ссылку вообще-то на онлайн-курс. Ну, можете сесть здесь. Кинули, но никуда больше не сообщили. Ну, все, короче, можете сесть там куда-нибудь, притворяться, что вы на паре. Okay, so, let's return. Now I'm explaining 7th task. What do you think? Probably I can explain again for them. What do you think? Or nah. Окей. Раскройте окошко слишком много и часть без намордника, а это плохо. Кстати, да, без намордника я не пускаю. Так что надень намордник, пожалуйста. Я приоткрою окошко, ты не замерзнешь, я в тебя верю. Тут тебя люди согреют. Так сказать. Окей, let's return. Наполовину открой, вот чуть-чуть. От себя. От себя. Дерни. Okay. So I explained Simon's task. It seems that it should be good if I explain again. Okay. So 7th task. There was a problem. Originally, I didn't know that regular quadrilateral pyramid, that regular should be also considered that we have lateral. Мы на паре телефон не используем, так что нафиг. Либо можно идти туда и флексить. Okay. So we have quadrilateral pyramid. In this case, we have lateral edges should be equal. We can prove that it won't work this because as A and as C length will be different. If we consider that we don't have regular, in this case, we are working, so we will have infinite number of solutions. And it should look like this. So we have our pyramid and different solutions. Now our goal to obtain. How? Actually, in my case, I decided that this task based on knowing, have deep knowledge in changing the basis domain. Because in this case, в телефоне сидишь, я говорю, все, говоришь, у нас без телефона, парень. Последнее предупреждение. I make MATLAB code for this. Okay. I need to find this. So in the end, I want to receive this basis. My basis will be x is AB, y it will be AD, and z it will be perpendicular to AC in the plane of ACC. Okay. I receive the equation of plane, and after this I take a ABC. ABC will be what? Normal to this plane. It's first one. This NACS. Of course, in our case, it's better to normalize all vectors. Why do you think? What do you think? Why we need to normalize all of them?
For generated basis.
You can have a basis without normalized.
But it would be.
Actually, your sixth task is not normalized.
It would be useless for solving this task.
Not useless, but it will be more complicated. In our case, it's better to work with normalized one. Second one, I tried to find this third vector. What is it? Cross product between AC and this one. Actually, using this way, I'm finding my normal to AC line. How? So we have this and AC. How can we find AC vector? We have 2 points, A and C. We can have an equation of line and take ABC will be our equation of line. I did there, so AC. Actually, we even don't need to do it because AC is, let's say, C minus A, and we receive a vector. Make cross product and normalize this guy. And the last one, so my first, let's sum up. My first intermediate basis was this one, and this one. Okay, not bad. But I want to receive finally, so we have right angle like this. But I want to have my own basis. So we need to continue to change it. How can you do it? So first of all, I found final new vector y. What is it? AC norm plus NIC. So AC norm, this one, and this one. We use vector summarization. It will be our, because we have 90 degrees there, we receive our 45 degree because we know that we should have a square. And of course, we have to just normalize this guy and receive like this. X-axis. Yes, you can do it in different manner. I decide, okay, we know that it should be 90 degrees between this vector and it was AB vector and AD vector. Let's take just cross product and we find this one. Of course, I will provide this code and so on at home. And normalize it. And the last one is this vector, perpendicular to AC. Now the most interesting part begins. Transformation matrix and how to solve this task. Now we need to remember this equation from Grodetsky book. I mean, Grodetsky is a slides, additional material from change the basis. How to solve like? new base equal to old base multiply on something. Not like it originally it was A, but in our case we have A there. Let's call it F trans. New base, what is it? Smart guy. Particular, precisely for this guy. It's this one, because we already found it. So it will be our AC norm. It will be our not AB actually, but we get what I'm talking about. These normal vectors for this, and this one. It will be there. Old bases. We have Cartesian space, so it's our old basis. And after this, we need to find this guy. I know that some of you failed in second task when you need to find, third task when you need to calculate matrix, and some of you didn't get how to take inverse matrix, but I hope it won't occur again. So we put it there with inverse, and then we'll receive this guy. So inverse I is an empty matrix, multiply on new vector. So actually, if we want to find only one particular solution, B and D, we can say that we solve this task. Why? Because then we receive this one. So we need to find coordinate B. What it will be? It will be F trans multiply on B prime and wait a second. First of all, we need to discuss what is it, B prime or D prime. Do you have any ideas what is it? I'm waiting the answer. Vector matrix of transition. Нет it. Okay. It's our x-axis. We know AC. We have square. That we know the edge of the square should be divided by square root of 2. Okay, what will be D in our case?
Zero AC.
Correct. Did you get? If no, I can explain again. Yes, no. No, you didn't get. Okay. Let's make a top of view. As somewhere else, it's A, C, B, D. What we decided that, okay, it's our X, it should be our Y, and our Z, it will be, do you know this notation?
Physics.
Yes, it's arrow, and cross, it will be that look like this and like this. So X, now we need to, so coordinate B is there. We are going along x-axis, we normalize it. So we already know that the length of X will be equal to 1. So we don't need to think about this problem like multiplication, division, and something. We know only AC because it's provided to us. We know this length. But we also know that it should be 90 degrees and it should be equal. You have square, so it will be in the same there. I hope you get it. Anton. Pink. Where did you miss something?
From vectors of They, you say that they look like 100.
Forget about, now we're talking about new bases.
Yeah, we change bases, but our
We didn't
vectors
change.
in first bases are not that simple because A is some point. Well, if you return to our points, A is some point in -3 to 1, and they didn't lie in the same plane if we roll. Right? Orthogonal vectors.
It's a second, it was a question. It's the full transformation matrix.
How from those vectors to its new origin, AX, AI, and IZ?
Yes. Now we're talking in new origin. It's in new origin we have this, because according to equation, new origin on transformation equal to old origin. We used to think that we are going from old to new, to communism and so on. But in reality, we are going from capitalist to communism, so from new to old one. It's a tricky moment in change the basis. Okay, we receive this guy. And of course, we can find D in the same manner. Plus A. Why A?
A is the change of origin because we start from difference between origin.
Yes, because we already start in C as because it's provided to us, and we go to A. We just shift our basis. Now, the most interesting part. We need to find the infinite number of solutions. How it can be done? Actually, you have this guy, and it's AC there, and we need to do like this. So we need to rotate our coordinate frame. I mean not coordinate, I mean our basis. There are two problems appears. One, we used to rotate around some particular axis. As you remember, I gave you some of you that Rx, Ry, Rz is this pure rotation translation matrices when we talk about homogeneous transformation. It's one part. How can we solve it? I will show you one solution and you will try to handle another solution. The first solution is just to know that we already have equation for this guy. So it looks like this. We need to find this vector and should normalize them. Our vector, it will be AC in new basis. We are talking about new basis now. It will be 1, 0, 0, 0, 1, 0. So, and we normalize the guy. Did you get? We go boom, boom. This one, it will be 1, 1. And we normalize it. And now, we use this magic. Our rod, let's call it like this, will be y plus v hat sine theta plus v hat 1 minus cosine theta. Do you remember what does it mean hat? Try to think. What should be there? So what should be other, guys? Matrix. So it should be also p by 3, and this one p by 3. So we need to make what? Skew symmetric matrix. Yes, exactly. I explained in the second class. And we can solve it. Actually, it also have a neat explanation, or a geometrical explanation. But you don't know what does it mean affine transformation, so it won't be clear for you. But let's discuss. So it's one solution. We receive this guy. Let's think how to solve this task in another manner, as you can solve it. So you need to find rotation matrix. You need to rotate your guy around something. How you can do it? Guys from previous group answered fast. Answered this question fast. Correct, yes, but how? Can you say me some translation? I am waiting solution.
By rotation matrix, we have a formula for rotation matrix for y axis.
So could you say me the precise around something, rotation, multiplying rotation, or whatever? What? So you have this task. How you can do it? I give you a hint. We know how to rotate around some particular axis, around x, around y, around z. We don't know how to rotate around some particular vector as I did it there. Now you need to solve this task without this knowledge. How?
We can sum up two vectors and get AC vector and rotate around it.
What I did there. It seems the same. Okay, next. We have time, don't worry, try to think. Anton.
No, I guess rotate around AZ while we.
So firstly rotate around the axis, yes?
Yeah.
What degree?
While we didn't get it, IX plus II equals AC.
You want to rotate around the axis about what angle?
Sorry, what is I matrix?
Identity.
Ah,
In Russian notation, it's also not only y, but yeah. Okay, let's try to think. We need to rotate around something. We know that we can rotate around some particular axis. Now, our axis won't belong to this. What we can do? Around the axis, 45 degree. Now, one of our, let's say, axis will lie on our line. What next?
rotate around the y-axis.
Parameter. That's it?
And again rotate around the axis.
Like this. Is it right? No. Try to imagine, because you have your fingers and you can imagine. Yo. It's wrong. The answer should be like this. What is it? What does it mean transpose? Yes, you're correct. I agree. Despite it. What is it?
In geometrical.
When we have special property of inverse matrix, of rotation matrix, that we don't need to take inverse matrix. We can take transpose matrix. It will be the same. Actually, now we wrote it in terms of fixed angles. We didn't cover it, but it doesn't matter. Do you know this or not know? Actually, the idea is following. First of all, we have RZ, 45 degree. After this, we rotate around this angle. And after this, we need to return, because how can we return?
Rotate was 100.
No, because your base is rotated. It changed. if you will rotate around this axis, as it was the previous one, what's the difference between Euler angles and fixed angles? Fixed angles rotate around some particular, I mean, you fixed your coordinate frame. So we have this frame. You rotate, but my original frame, like this. And when we need, so we do like this, and we are returning according to this frame. And we receive our needed result. Actually, the guy from previous group answered on this question, even without knowing.
Why do you transform matrix, transpose matrix instead of inverse?
You can write inverse there.
It would be the same for.
Of course. Inverse for rotation matrix, you know the property that R transpose equal to R in the inverse, and it was in lecture, if not mistaken. Okay, so for solving this task, we need to understand where we need to put the rotation matrix. I made a mistake when I coded it, but I solved this fast. So we can put it there, 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 there. Where do we need to put it? What do you think? So you have rotational matrix. You need to put somewhere to solve our task. Where do we need to put it? So this, where? Okay, your idea around A. Other guys, what do you think? Where we need to put this rotation transformation matrix? What?
Around the AC.
So you can put rotation there, 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 and there. There. What do you think? Move it there. Move it there.
We rotated after change the basis, and I think because at first we changed the basis to multiply the transition matrix, and then we secondly changed the basis.
Actually, he is right, and I did this mistake before when I see. We are working there in new basis. I mean, in new basis, and we rotate this in a new basis. We are rotating in a new basis. We actually don't change the basis itself. I mean, we didn't expand it, we just rotated. And after this, we transform it to old basis. If you put rotation there, you try to rotate old basis. So yes, you're right. You put rotation there, and as I put it in the code, and transpose rotation B plus A. Hooray, we solved this task, and it works, you may see. Of course, I will provide all this part. Yes, it seems it will be a bit overcomplicated for you to solve this task during the midterm, but if you know the algorithm, it can be solvable.
I think it can be solved without
How?
This is from offline. We can know the meter of BD vector. For example, hash point SH BD. Their cross product is parallel to RC. And we know also hash point on the RC. Then we can.
How to define this point? It can be changed. Yes.
On BD. Middle of BD.
Yeah, it's middle of BD in our case, if you may, but in this case it won't be cross product works, because product give you a perpendicular. Perpendicular won't be in the center. You may see. that if I take perpendicular to this plane, it will be not in the center. It's applicable only in one case. So to sum up, this task should it's challenge for you to understand how to work with bases, with changing the bases, because you may see we did it a lot, and if you understand how to work with it, you can solve this. Otherwise, you'll fail. Yeah.
Well, we can solve it using maybe defining, for example, big coordinates as some variables, for example, ABC, and having these coordinates, we will use just maybe two parameters, I think two parameters, I got two parameters with unknowns, and using them just show the coordinates. I mean, here we have angle as parameter. But in another case, we can use
Yes, but it will be connected. So also you need in this case to provide show that you have two parameters, but they depend to each other.
Yes.
So if you show that independent nature, actually you did the same, because in your case you have x, y. I mean alpha, beta, and you show that alpha depends on beta, and your coordinate cosine and sine will appear in this case. Okay. Now we discuss the challenging task. Let's go to the beginning. So go to flex tasks. Okay, the first one. I hope. Okay, the algorithm.
Find the point of north.
Not first of all, you need to find the line probably. Oh, no.
Yes, find the point of north, and then we find direction vector of the line, then get some point from this system of linear equation. It would be a point on this line, and then using canonical form, we find the equation of the line, and then using formula find the distance from point to the line.
To sum up, we do 3 steps. First of all, we have general form. We are going to canonical form. It was in a class on slides. After this, we just open my slides, open distance from point to line, and solve this task in 2 steps. So I don't see any reasons to discuss about this flex task. Go, okay. Solution tips. Today I got up at 8 and 40 minutes and I haven't had the slides. So I add in one hand and make slides in other hand. So I will add additional information there. Okay, second task. Orthocenter, it was a result task, but I decided that it will be better to put intersection of altitudes to slide. Because as for me, okay, what's the difference between orthocenter and centroid? And I decided, okay, I think I'm a dummy and my students also dummies, so I will put it there. How to solve this task?
Or draw.
Okay, you draw it. And you will receive a precise solution, yeah?
Yes, then use ruler and...
Okay, congratulations, I like your solution. Okay, Zhenya, how did you solve this task?
I don't remember, but I used a perpendicular.
Yeah.
At the end of the test, it was 0.
And
for the tailored product, after equals 0.
Did you get why you should work like this? Oh, these dummies who don't remember the equation that AD multiply BC equal AD transpose BC.
Sorry, why do you use the transpose BC if the direction is not
Why? BC and
AD should be
BD in
No,
second
second
equation.
BC, yeah? Okay. I didn't think, I just wrote like a simple guy. Students told me, I just went. Okay. So why it works like this? We have 2 equations. I mean 2 variables x. I mean c or whatever. cx, cy, and we have two equations. And we just solve this task. 1 minute, one task. Let's go. The most complicated task ever. Why? Because if you forget how to multiply matrices, as some of you did, you cannot solve the first one. But I'm interested in second one. Okay, first of all, why the second task is very helpful there? Because if you receive no solutions or infinite number of solutions, one solution, you can check it during the drawing. First of all, we need to get, because some of you ask me, how can we find the planes? We can rewrite this. Actually, originally, even me didn't get so that it's planes because it doesn't exist. It didn't exist before, so we put it there explicitly. Not really. I think. So actually, it can be transposed as like ax plus by plus cz plus d equal to 0, d it's minus b. Can we draw this guy?
Yes. If we know A, B.
We know it because 1 minus 3, 1.
Yes.
Even more if you know how to do like this.
We can just get 3 points and connect them and what
Dummy solution. Other.
You know equation of a plane, then we can find the intersectors form of this plane.
In sections. We use in sections form. It will be x divided by
D divided
something.
by
Okay, I'm just kidding that I don't remember this formula.
D divided by no.
Minus d divided.
No. D divided by no.
Why can't we express it as a system of linear equations?
It would be system in 3 equation plane. 3 equation
And
plane.
what?
You can draw it in sections, you can draw it easily because these points, you can just put it on x, y, and the axis, and you will receive a plane.
We can just substitute 0 instead of x and
Different,
y. And
of course, you can do it like this. In this case, it's just, you need to divide by d, and that's it. After this, I just like a dummy, took 1 point, it will be minus a divided by d, second point, and third one. And I did it 3 times more because I have 3 planes. After this, you can check, okay, why do we have infinite number of solutions?
because they intersect on the line.
Yes, we have line intersection, so it should be like this. And for instance, it should be parallel or whatever. When we have one solution, when it intersects one point, when we have no solution, when points they are parallel to each other, like this. And that's it. Yeah. Fourth one. It's task from tutorial. So you're opening tutorial.
1 minus d2 divided by.
Oh yes, one equation. So either you, if you don't remember how to solve it, open tutorial and you will get it. Piece of cake. There? So you need to draw planes, 3 planes. A, B, this is a plane. This equation of plane. You have 3 equations of plane. 1, 2, 3. So difference of the draw relative positions. I see some of you cannot read. This very fancy, difficult, and awesome word. Okay. The fifth one. Actually, how can you solve this task?
Draw.
Yes, actually, the reason why I wrote you to take ruler and this one. I forgot this. Transportir. Okay, if you have cells, how can you solve this task? Cells in your sheet. You know that 30 degrees, 1, 2, 3, 1, 2. It's 30 degree. 30 degree. This line, you can have this line by ruler. And after this, hop, hop, and you solve this task. So you obtain 4 points, and after this, you can just make for, how to say, you have
also you can use school drawer if you
of either one, you can, yes, you know this point and this point. After this, you just need to take cosine sign and receive this point. What's the difference between variants? I change only M and horizontal vertical. Only these two, yes. So on some variants, I change the M and some, yeah, sure. Okay. So this task is also, let's say, sleeping task for you. The last one, Puzankov's one. Oh, who wants to solve it on the whiteboard? Anton, I want to see. Did you solve this time at endurance? Okay. Я думаю, что еще мы проверим. Потому что мы решили проверять по задачам. Что за бред сейчас? Поэтому придется друг другу передавать бумажки. Никто не слышал. А мне было лень проверять. Я занимался другими делами. Проверили. Седьмую задачу теперь мне нужно проверить для себя, а не для вас. Буду знать по умным компьютерам. What are you doing?
Write coordinates of the Earth in IJ.
Yeah. So you try to obtain the basis. Coordinate of basis.
Yes, now write widgets. We need from by 1 to 3 I show x2 equals same coefficient 1 1 x1 plus some coefficient 1 2 to y1 and y2 is the coefficient which is 1 x1 is coefficient 2 y1. And now we just want to calculate coefficients.
But what about shifting?
Yeah, but we just need transition matrix, right? Well, the shifting from origin 1 to origin 2 is just 0, 2. We can say that the change of origin is 0, 2, but we need just find the transition matrix. First system will be minus 3 equals 1.
Очень просто окружали. Снизу я решал.
Помнишь, мы сегодня говорили про ОГРТ, что у тебя вначале идет информация, но ты говорил, что ты не с этого нижнего идешь, наоборот, у тебя ты находишься в новом базисе и получается не старого базиса. На в новом базисе, поднять в новом базисе, в новом базисе.
Actually, what is the answers?
What?
Have you got the answers to all the stuff?
Probably I will have answers when we'll check the task. It seems that you're correct. I just took from your variant. Actually, I had the same. I did the same when I was previous years. I just gave task to the students. I say, okay, we have the most the most guys solve it. Have this answer. Okay, it's right answer. And you solve it. Actually, can we solve it in different manner?
Maybe, but
You need to go away because nobody can see it from the camera. Yes, toy. I mean, we are working on online students too, you know?
yes.
Okay, how can we solve it in different manner? I mean, yes.
Find condition.
Rotation and scalar matrix.
Actually, you can consider another way that we have the same vector. We assume that we want to find one vector. The vector will be the same for one basis and another basis, but coordinates will be different. So we want to find v1 on something plus something equal to
Yes.
and your solution will be from so v1 and this guy should be there.
We can remove change between origins or swap it to one side.
Yes, of course, you need to swap it and solve this task. Yes, so it's one of the possible ways. It's more straightforward because as for me, I'm a bit scary of this notation.
Yes.
Yes, it looks like you're a very smart guy. I am stupid guy. I am prepared this notation.
I'm afraid of this notation because it's much more simple.
Okay, so there are two possible ways. So he is smart, Anton. Today or yesterday on sparrings, he kicked some ass. Okay, so you can write it this way because the nature of it, that vector is the same. Vector has the same number despite of the bases, because you can move vector, but the base will be the same. And you are operating with coordinate systems, and you just solve this one and parade. So you can take it. Okay. Yeah, sure.
In John, there was the maximum 35 terms, and the midterm evaluation is 30. So, does it mean
What do you mean in term evaluation?
midterm weight for the course is 30%?
I actually would like probably should be 35. Maybe he made some mistake. So 35 is all 35 will be your midterms. Попробуй просто дома нарисуй задачку, вот прям возьми тачку. It can be wrong solution because I didn't check, but the core idea should be like this. I mean, from you, because the common problem that some of you can make a mistake that when you want to find the transition matrix between two bases, it will be like this: that new bases equal to old bases multiplied by a, but x old equal, let's omit shifting part. Yes, получается a x transpose, it's new one. Old. I mean just that some people make mistake. Because most of the time you want to make like this, but it's wrong. Okay. So do you have any questions? Maybe not related to the midterm, but others. A new
What
topic.
is the formula?
What?
How to
Actually,
get this formula?
this equation appeared from assumption that let's see. I can send you it will be easier for you. Because actually it's about affine transformation. Affine transformation we will cover 3 weeks later probably. I will, if we won't cover it during the class, I will explain in our classes, but we need to have more material for this, for understanding this, for the thing. Next topics will be about conic sections and so on, and some fancy words like hyperboloid, hyperboloid, paraboloid, and so on. I will try to explain it using CAD systems, because in CAD systems you can easily make sections. You can cut some detail, some object, and understand how it should look like. Actually, I learned this topic when I studied in Bauman State University using CAD systems. For me, it was easier. Other questions? Yeah.
I have a question about first task. Can I solve it using differential equation?
Why do you need derivative there?
I find отрезок
line section
with the line and point, and I need to find the shortest. And to find it, I use differential.
Poor Riza. Okay.
It is his task.
Yes, first and second is his task. I don't know. I need to see a solution because it sounds really okay. It's like I took a bazooka to kill I don't know an ant.
I find absolute value of
I think this is normal solution because we can derive a formula of distance between one point and any point on the line and express.
It seems yes, it should work because of nature of derivatives. Yes, but actually some tasks can be explained either using. It's a good question because you didn't cover least square. Least square I briefly explained at previous time. What does it mean least square? When you have так, Галю, потом пошепчетесь друг другу на ушко. Okay, so we have a line. For making line, we need 2 points. So it's two system linear equations, like I don't know. 1 equal b plus x. No. X plus b. Okay. Like this. So second one. But okay, if we have more points, we will have some particular solution. If we have this point, we cannot solve this task. But we can solve the least square problem. We can try to solve this task, minimize the error. So in this case, we can draw a point like this. And it's called least square solution. It's widely used in data science, in machine learning, or many places. And it will be on the next semester. And in this case, actually, you can solve this task using either derivative equations, because you try to minimize, you try to solve optimization task. You try to minimize error. Error this one. E1, E2, E3. Or you can solve it using least square solution or pseudo-inverse. Pseudo-inverse will be explained probably in the last class because we don't need it for now. So using using SVD, you can take inverse matrix of any matrix. It can be either square or it can be rectangular or whatever, using pseudo-inverse matrix. Left and right pseudo-inverse. It's just a bit little spoiler for you. That now you can look smarter. So it seems that's it today.